Chapter 2, summarizing graphing the data. And we're going to talk about other way of graphing data. Okay, so other type of statistical graphs, and the popular ones, our objective is to identify a suitable graph for presenting and representing a data set. The graph should be effective in terms of expressing the need of the data set, or revealing the important characteristics of the data. And the thing is, there's abuses, also misuses of the graph. Some of the graphs are bad in the sense that they contain errors, meaning it's not objective representation of the data set itself. Some are bad because they are technically correct but misleading, using some instrument to distort the data set, distort the graph to make it look misleading. It's important to develop the ability to recognize the bad graphs and then how people try to mislead using a misleading graph. Okay, so first of all, another important graphing tools is called scatter plot. You can also call scatter diagram. So for the scatter plot, we have a horizontal axis. So this is typically the independent variable. So in this case, waist circumference is independent variable, and dependent variable is arm circumference. So as you try to depict dependent variable, arm circumference depends on the waist circumferences. So horizontal axis and vertical axis. So you get order pair, and each order pair becomes a dot on the graph. Okay. And now from there we get a scatter plot, and we try to investigate using the waist circumference to make the prediction about the arm circumference. To predict the arm circumference. And this technical analysis is what we call the linear regression analysis. And we're going to talk about this in chapter 10. So if you look at the scatter plots, you can see when the waist circumference increases, so the overall trend here is when the waist circumference increases, then the arm circumference increases. Okay, so this is what they call the direct or positive relationship, correlation, between those two variables. The scatter plot actually helps capture the relationship between two variables. We call those two variables independent variable and a dependent variable. Now, second important tool is what we call a time series graph. So most of the financial data is presented using a time series graph, financial data. And if you look at this particular example, it's time series graph. On the horizontal axis, this is time in years. And the vertical axis represents Dow Jones Industrial Average, the yearly high value of the Dow Jones Industrial Average. Okay, so you get a guess this kind of graph, and then connect using every 2 points using a line. Okay, so you get this typical time series graph. And also you can analyze this graph. You see the overall trend here is increasing, meaning as time goes by, the yearly high value of Dow Jones Industrial Average increases over time. You can also see some cycle effect here. You see, this is a typical cycle here. So there are a lot of elements you could analyze in terms of time series graph. And then the next tool is called dot plot. So for the histogram data set, we talk about low level IQ score. Okay, that we can represent the data using a dot plot. So on the horizontal scale, we're putting the IQ score 50, 60, 70, 80. And as you can see, most of the data will be concentrated right here, which is the, in terms of the histogram, it's the middle two, right? The middle two, which has 33, frequency of 33 and a 35. This is where this is. So the majority of the data is concentrated right in the middle. So we will call this, you can also, if you look at it, you can fit a bell curve here, right? So, and the dot plot is very good visual tool to help you see the distribution of the data set. And then next one, stand plot, also called stand leaf plot. So this is what they call the stand part. Stand part is here. This is the leaf part. So this is a stand, and this is a leaf. On the stand part, usually it's a 10th digit and a 100th digit. 10th and a 100th digit. Hundredths. Okay. Tens and hundredths digit. On leaf size, it's 1 digit typically. So for the IQ score data set, it's very convenient to use stand plot. So as you can see, you can, for the first category, you have 50 and 56. Lowest IQ score 50 and 56. So just distribute this, look at that. The highest IQ score in this case will be 141. One for one. And as you can see, you can list all the IQ scores based on the stand plot. So for this scale, you get 111, 115, another 115, and 118. So that's how we get all those 4 IQ scores. So stand plot actually gives us the visual representation of all those IQ scores presented in different categories. And then we also have a bar graph. So use bar graph to show frequencies of the categorical or qualitative data. Vertical scale usually represents frequencies or relative frequencies. And horizontal scale usually identifies the different categories of quantitative data or categorical data. And a multiple bar graph has 2 or more sets of bars. And it's used to compare 2 or more different categories of the data set. Let's take a look at this. This is a multiple bar graph. Right here, we try to compare the median income by gender. Blue one represents a male, and then a pink one represents a female. As you can see, from 1950 all the way to 2010, there's a gap. There's an income gap between the male and the female. So the male workers always make more money, earn more incomes compared to their female counterpart. So by presenting the graph presenting the data set in this particular form, you can easily compare the income gap between those 2 genders. As you can see, the horizontal axis is the year. Okay, and the vertical axis, and then it's median income. Okay. And then we also have Pareto chart. On a Pareto chart, the horizontal axis is always categorical data or qualitative data, categorical data. Or qualitative data. And vertical axis in this case is %. So the question here is what contributes most to happiness? So we have 6 major categories. First one is family and partner, second one is friends, third one is leisure, fourth one work and studies, and music, sports, right? As you can see, the family and partner contribute most to the happiness. The next one will be friends. So using the Pareto chart, you can see this is number 1, number 2, this is 3, 4, and then 5, right? Fifth contributor towards the happiness. You can easily find out the comparison among those different categorical data. And we can easily convert a Pareto chart to a pie chart. So depends on your needs. You can use Pareto chart to represent a data set or the pie chart. So the pie chart basically just draw a circle, and the family and partners here, it's above 65%, contribute 65% towards the happiness. And based on the percentage of each category, we'll be able to come up with this breakdown of the entire pie, right? So each slice represents a percentage contribution towards the happiness. So typically on a pie chart, each slice represents a percentage. So we use percentage to separate different categories here. And we also have frequency polygon. In a frequency polygon, right here on the horizontal axis, we're using the midpoint. So this is like the derivative from the frequency, right? So this is the derivative of the frequency distribution table. So this graph comes from the frequency distribution table. And the horizontal axis is midpoint, as I mentioned. All of these are midpoint. The vertical axis is the frequency. Okay. As you can see, the middle two is 33 and 35. And that's 2, right? 7. And that's 1. Okay. That's what we have from the original, frequency distribution table. And now just connect each two with a line, you come up with a frequency polygon. And you can easily find out the distribution of the data set from the frequency polygon. We also have a relative frequency polygon. So again, on the horizontal axis, it's still the midpoint, and the vertical axis becomes a %, which is what we call the relative frequency. Yeah, so if you look at lowland group, and using relative frequency polygon, we can easily compare the highlight group versus lowland group. As you can see, for the lowland group, the IQ score tends to be higher, right, compared to the highlight group. So relative frequency polygon again is a derivative of the frequency distribution table. Okay. Now ODrive. This is pronounced ODrive. Okay. And ODrive is also a derivative of a frequency distribution table. And then again, on the horizontal axis is the class boundary. So we're using class boundary here on the horizontal axis. And the vertical axis is cumulative frequencies. Okay. So if you, as you can see, you can analyze this here as 35 of the IQ score less than 89.5, right? And here, if you want to interpret this, look like 68 of IQ score are less than 109.5. Okay, and then the last one will be is this 70 of the IQ scores are below. If you look at this particular point here, 70 of all IQ scores are less than 129.5. So you can use the ODrive to get a lot of information, write a summary sentence about breakdown of all these IQ scores. And then also some graphs are misleading. Also, you can say that they are deceiving graphs. Like these two graphs representing the same thing, right? They compare three vehicles, Honda Civic, Chevrolet Aveo, and a Toyota Camry. And if you look at the first graph, it's more dramatic. Second one is, as you compare all these mileages, highway fuel consumption, so we also call them mileage. As you can see, they are pretty consistent, meaning they are at the same level, right? Similar level. But if you look at the first graph, it looks very dramatic, meaning Honda Civic is way better compared to the other two vehicles. So the reason why the graph looks like this, because they did a distortion on the vertical axis. So that's a distortion here. So they distort data on the vertical scale. So if you look at it, this is the scale starts on 30 all the way to 36. And then if you look at a second graph, which is more objective graph, this is a proper representation of the data, and they look pretty consistent, meaning all three vehicles perform in a similar level, because the scale they pick here is more like standard way of picking a scale, which is more objective and giving you more objective outcome. So this is one way to deceive the viewers or audience, your audience. If you distort the vertical axis, it's like you zoom in on the vertical axis to a certain interval, then your graph will look very dramatic, right? Like this. So some in the advertising industry, they usually intentionally do that to deceive the customers, to show Honda Civic is way better compared to the other vehicle. But in reality, that's not the case. Actually, they are very similar. They perform similarly in terms of mileage. Okay, so this is one way to create a misleading graph and then to achieve a certain purpose. And also look at the second example here. This is income and education. As you can see, they use a 3D graph to representing this different education level with the income level. And the thing about the 3D graph is, and this is misleading, because if you look at the no high school diploma, they're making $18,734. And advanced degree, they're making $74,602. And this cube here is like, this is 4 times, so this is cube is 64 times as much as the first cube, right? This first cube. So last cube, the fourth cube, is 64 times as much as the first cube. However, if you look at the reality, you see $74,602 is only 4 times as much as $18,734. So definitely this is a misrepresentation. So this graph is also misleading. Now, so if you're using 3-dimensional boxes, the chances you basically try to create a misleading graph. It doesn't actually represent the actual difference between all these different education level compared to their income level. Also, some graphs are not very clear in terms of achieving a goal. In this case, income and education, you can present it in this particular form, but however, this graph doesn't show a clear difference between all this education level and the income level. You see the bars has the same width, and also it's too difficult to understand, what the creator of the graph really tried to demonstrate. So this is also kind of misleading, graph. Or you can say it just doesn't demonstrate the outcome of this particular comparison of the income and education. And this is a fair and objective graph right here using a bar diagram or bar graph. You can easily just get a visual comparison between different education level and income level. And as you can see, vertical scale was picked carefully, so there's no misleading situation occur here. That's why the last graph is the best graph to present a fair and objective relationship between the income and education. And then some important principles suggested by Edward Tufte. So for smaller data set of 20 values or fewer or less, you can use a table instead of a graph. The table is, you can easily get a breakdown from the table instead of a graph. So table is more effective compared to a graph. And the second important principle, a graph of data should make the viewer focus on the true nature of the data, but not on the distracting design features or ambiguous design features. They usually mislead the audience to the wrong direction. Also, third guiding principle is do not distort data. And on the vertical scale and horizontal scale, especially on the vertical scale, you should always try to construct a graph to reveal the true nature of the data. Also, almost all of the ink in the graph should be used for the data, but not for the design, not for the other design elements. You should concentrate on deliver the true characteristics of the data set, but not just try to focus on certain facet of the data set.